welcome you in the lecture series of random processes, detection and estimation. It is 32nd lecture of this series. In the previous lecture, we have discussed the general linear model for finding MVUE. In this lecture, we will discuss the sufficient statistic to find MVUE. The outline of this lecture are sufficient and minimal sufficient statistic, and verify the sufficient statistic, and then we will discuss Neyman-Fisher factorization. In the objective of this lecture, you will able to explain how the sufficient statistic is used to find MVUE, and also you will able to explain how can you verify the sufficient statistic and how Neyman-Fisher factorization is used to find the sufficient statistic. Now we will start with the sufficient and minimal sufficient statistic. We know from the previous lectures that the evaluation of the CRLB results in efficient MVUE. If an efficient estimator does not exist, we are still able to find MVUE using sufficient statistic. So where the CRLB cannot be established, a more general approach to find MVUE is required, and this approach is based on first finding the sufficient statistic for the unknown parameter, and a sufficient statistic with respect to the statistical model means PDF is a statistic that contains all information about the parameter associated with the model available in the sample observations. Let xn is equal to a plus omega n, that is DC level A in white Gaussian noise. We know that the sample mean a cap, it will be equal to summation n0 to n minus 1 xn is the MVUE with minimum variance sigma square by n. And if we choose a bar is equal to x naught is our estimator, even though it is a unbiased, its variance is much larger than the minimum variance. This poor performance is due to discarding the data samples x1, x2, xn minus 1, which carry information about DC level A to the estimator. So here should be a question: which data samples are present for the estimation problem, and or does there exist a set of data that is sufficient? The following data set may be claimed to sufficient in that they may be used to compute a cap, and let the set S1 that involves x0, x1 to xn minus 1 means original data set which always sufficient for this problem. And other set is S2 which involves x0 plus x1 and x2, x3 up to xn minus 1. And S3 set it involves x0 plus x1 plus x2, x3, x4 up to xn minus 1, and S4 is summation n0 to n minus 1 xn. So for this problem there are many data sets. The data set that contain the least number of elements is known as minimal. If you think that the elements of these sets as statistic, we say that n statistic for S1 are sufficient, n minus 1 statistic for S2 are sufficient, n minus 2 statistic for S3 are sufficient, and a single statistic for S4 sufficient. This statistic summation n0 to n minus 1 xn being a sufficient statistic. This is minimal sufficient statistic. So the statistic S4 is equal to summation n0 to n minus 1 xn is the sufficient statistic. So we no longer need to individual data value since all the information has been summarized in the sufficient statistic S4. And to understand this, consider the PDF of the data Pxa is equal to 1 by 2 pi sigma square to the power n by 2 into e to the power minus 1 by sigma square summation n0 to n minus 1 whole square of xn minus a. Let Tx is equal to summation n0 to n minus 1 xn is equal to t naught is observed, And after knowing this statistic Tx, the PDF changed to the conditional PDF as Px when test statistic at T naught is given. It is x summation n0 to n minus 1 xn, which involve the unknown parameters a, and which gives the PDF of the observation after the sufficient statistic has been observed. Since this statistic is sufficient for estimating A, this is conditional PDF should not depend on A, and this means the conditional PDF Px by Tx is equal to T naught given A. This means this conditional PDF should not be depend on A. This means it will be equal to P conditional PDF Px by Tx is equal to T naught. To find this conditional PDF, first we need to verify the sufficient statistic. The verification of sufficient statistic, let the PDF Pxa is equal to 1 by 2 pi sigma square is to the power n by 2 into e is to the power minus 1 by 2 sigma square summation n0 to n minus 1 xn whole square of xn minus a, and let Tx is equal to summation n0 to n minus 1 xn is sufficient statistic. We need to determine the conditional PDF, and the conditional PDF is Px by Tx is equal to T naught given A. It will be equal to from the base theorem, it is Tx is equal to T naught A by Tx is equal to T naught A, and I can write it as Pxa delta Tx minus T naught upon Tx is equal to T naught A, and because this part takes the non-zero values only when x satisfies Tx is equal to T naught, and here delta is the Dirichlet delta function. The Dirichlet delta function. You can also show that Tx is the normal random process with mean Na and variance n sigma square. So we can have Pxa delta Tx minus T naught, it will be equal to 1 by 2 pi sigma square is to the power n by 2 into e is to the power minus 1 by 2 sigma square summation n0 to n minus 1 xn minus a whole square into delta Tx minus T naught. And we can also write it as 1 by 2 pi sigma square is to the power n by 2 into e is to the power minus 1 by 2 sigma square into summation n0 to n minus 1 x square n minus 2a T naught plus na square into delta Tx minus T naught. So from the equation first, and from this equation we can have here Px by Tx is equal to T naught with a, it will be equal to 1 by 2 pi sigma square is to the power n by 2 into e is to the power minus 1 by 2 sigma square summation n0 to n minus 1 x square n into e is to the power minus 1 by 2 sigma square into minus 2a T naught plus na square divided by 1 by under root 2 pi n sigma square e is to the power minus 1 by 2n sigma square T naught minus na and whole square of this T naught minus na into delta Tx minus T naught, and which does not depend on a. So, and it can be written as under root n by 2 pi sigma square is to the power n minus 1 by 2 into e is to the power minus 1 by 2 sigma square summation n0 to n minus 1 x square n into e is to the power T naught square divided by 2 n sigma square into delta Tx minus T naught, and which does not depend on a. So we can conclude that summation n0 to n minus 1 is the sufficient statistic for the estimation of a, and this example indicates the procedure for verifying that the statistic is sufficient. For many applications, it is not easy to evaluate the conditional PDF. So the first guess the sufficient statistic and then verify its sufficiency is quite unsatisfactory in the practice. To avoid the guesswork, a simple procedure termed as Neyman-Fisher factorization can be used for finding the sufficient statistic. There is one theorem related to Neyman-Fisher factorization, and if the PDF Px theta can be factorized as Px theta is equal to G Tx theta Hx, where G is a function of Tx and theta only, and Hx is a function of x only, then Tx is sufficient statistic for theta. Conversely, if Tx is sufficient statistic for theta, then PDF Px theta can be factorized as Tx theta is equal to G Tx theta Hx. Conceptually, one expects that the PDF after the sufficient statistic has been observed, the conditional PDF Px by Tx theta should not depend on theta. Since Tx is sufficient statistic for the estimation of theta, no more knowledge can be gained about theta once we know the test statistic Tx. So let us take one example. Consider the DC level A in white Gaussian noise xn is equal to A plus omega n, where omega n is the random process with mean zero variance sigma square. Then PDF Pxa, it will be 1 by 2 pi sigma square is to the power n by 2 into e to the power minus 1 by 2 sigma square summation n0 to n minus 1 whole square of xn minus a. And let sigma square is known. Verify the sufficient statistic here. So to show that the factorization exists, the exponential of the PDF, this part, this exponential, it can be written as summation n0 to n minus 1 xn minus a whole square. It will be summation n0 to n minus 1 x square n minus 2a summation n0 to n minus 1 xn plus na square. So the PDF can be factorized as here Pxa is equal to 1 by 2 pi sigma square is to the power n by 2 into e to the power minus 1 by 2 sigma square na square minus 2a summation n0 to n minus 1 xn and into e to the power minus 1 by 2 sigma square summation n0 to n minus 1 x square n. And this part is Txa because it involves the data xn and the a, the non-parameter a, and this is hx. So the tx means summation n0 to n minus 1 xn is the sufficient statistic for a, and also 2 summation n0 to n minus 1 xn is also sufficient statistic for a. So any one-to-one function of summation n0 to n minus 1 is the sufficient statistic. So sufficient statistics are unique only to within one-to-one transformation. So let us take one example. Let xn is equal to a cos 2 pi f naught n plus phi plus omega n, where small n is from 0 to n minus 1. And omega n is the normal random process with mean zero variance sigma square. A is the amplitude, f naught is the frequency, phi is the phase to be estimated. And here, first of all, verify the sufficient statistic. You know the PDF Px theta, it will be equal to 1 by 2 pi sigma square is to the power n by 2 is to the power minus 1 by 2 sigma square summation n0 to n minus 1 and whole square of xn minus a cos 2 pi f naught n plus phi. This is equation first. Now the exponential part of this PDF is summation n0 to n minus 1 and whole square of xn minus a cos 2 pi f naught n plus phi, and it will be written as summation n0 to n minus 1 x square n minus 2a summation n0 to n minus 1 xn cos 2 pi f naught n plus phi plus summation n0 to n minus 1 a square cos square 2 pi f naught n plus phi. And I can also write this as summation n0 to n minus 1 x square n minus 2a into summation n0 to n minus 1 xn cos 2 pi f naught n cos phi plus 2a into summation n0 to n minus 1 xn sin 2 pi f naught into sin phi plus summation n0 to n minus 1 a square cos square 2 pi f naught n plus phi. And here we cannot see that the PDF is factorable as required by the Neyman-Fisher theorem. So no single sufficient statistic exists here. However, it can be factorized as it is Pxa is 1 by 2 pi sigma square is to the power n by 2 e is to the power minus 1 by 2 sigma square summation n0 to n minus 1 a square cos square 2 pi f naught n plus phi minus 2a t1 x cos phi plus 2a t2 x sin phi into e to the power minus 1 by 2 sigma square summation n0 to n minus 1 x square n, and where t1x is summation n0 to n minus 1 xn cos 2 pi f naught n, and t2 is summation n0 to n minus 1 xn sin 2 pi f naught n, and we can have this g t1x t2x, and this is hx. So here we can see that t1x and t2x are jointly sufficient statistic for the estimation of phi, but no single sufficient statistic exists here in this case. So far in this lecture we have discussed about sufficient and minimal sufficient statistic to find MVUE. Also we have discussed how to verify the sufficient statistic, and this was 32nd lecture of the lecture series of random processes detection and estimation. As you have seen that in this example 106, there is no single sufficient statistic exist, but we want to restrict our attention to the single sufficient statistic, and why it will be cleared in the next lecture. Till then, thanks for listening this lecture. Thank you.